Command term explain how means a step-by-step instruction. Keywords are buffer solution and half-equivalence point. The concept here is the pH of buffer solution at the half-equivalence point. Starting from a titration curve, the half-equivalence point is exactly its name, the halfway between the starting point and the equivalence point. For example, if it takes 50 centimeter cube of an acid to neutralize the base, the half-equivalent point is at the 25 centimeter cube. One key thing about the half-equivalence point is that it's in a buffering region. Buffering region means that the solution at this point can resist a small amount of added acid or base without changing the pH. This is why this part of the curve is flat. Another key thing is that the pH at this half-equivalent point is equal to pKa of the starting acid titrate. The pOH is equal to the pKb of the starting base titrate. Back to our questions, it really doesn't matter what the titrant is. The pH at half-equivalent points only depends on the starting titrate. The answer can be written in bullet points. The pH at half-equivalent points only depends on the starting titrate. The titrate here is ammonia, which is a weak base. pKa from section 21 of the data booklet is, let's see, 4.75. pOH is equal to pKb of the starting base titrate. The pOH is going to equal 4.75. Now the last bullet point, it is 298 K, so room temperature. Therefore, pH is equal 14 minus pOH. 14 minus 4.75 is equal 9.25.